Hey developers, welcome to the hands-on guide on building secure backend services on Solana. Today we are moving beyond theory to programmatically create and enforce transaction-based policies using Coinbase Server Platform Server Wallets V2. For too long, automatic on-chain actions has meant accepting significant risks from compromised fees or application-level bugs. The CDP policy engine is designed to solve exactly that. It acts as a powerful programmatic firewall for your server wallets, allowing you to enforce rules at the API level before a potentially disastrous transaction can ever be signed. Today, we are going to build a Node.js script that demonstrates the most powerful security features of the Solana integration. A script will set up a Node.js environment with CDP SDK, create foundational Solana policies like address allowlists and token restrictions, create an advanced IDL-based policies to secure interactions with the Jupyter Stack aggregator, assemble a complete runnable script to create all policies in one go. This tutorial is a one-stop shop for mastering programmatic server-side security on Solana. Let's get ready. First things first, let's get an environment ready. This will be a TypeScript project which gives us great type setting when working with the SDK. The prerequisites are you need Node.js version 18 plus installed in your machine, a Coinbase Server platform account, your CDP API key credentials. To get your CDP API key credentials, log into the Coinbase Server platform portal, create a new project, create new API key credentials like the API key ID and the API key secret, and generate a new wallet secret. So I'm already on my terminal over here, and first we'll create a new directory for our project. So NKDS, Solana policy, and Jindobo. I'll just navigate to those directory. So first we'll initialize Node.js in this directory. So npm init-raw. So this initializes the package.json, and we have initialized the Node.js environment. Now we'll install the dependencies, and after that we'll initialize TypeScript for our project. So already have the dependencies, which should be first of all the most important dependency, which would be the Coinbase CDP SDK. With this, we'll initialize the CDP SDK and create various transaction-based policies for Solana. .env for managing environment variables, LSP for setting up TypeScript for a project, TS node for setting up TS node and types node. So I just hit install. So we'll just wait for the installation to complete. Once the installation is done, we will configure TypeScript for our project. So I already have the command. So we'll use the npx command or npx psc-init and the various others are the parameters for the TS configure. So I make sure the root date, SOC out there, Postgres, and the ES module interop, and making sure that the module is also set up properly so that we don't have any issues with input statements as well, and the module resolutions. So I'll just hit enter. So this will create a new TS config.json. So once this is done, we are done with all of the major environment setup. After this, we'll set up the file folder setup for a project. So now I opened up the project here in IB. So first we'll set up the SRC folder. So I'll just set up on SRC folder. And here in this folder, we'll create a solana.ps. So this would be the main TypeScript file with all of the Node.js script that we are going to create. Once this is done, we'll set up the .env as well. So this .env would have three main credentials: the CDP API key secret, the CDP API key ID, and the CDP wallet secret. So I have all the credentials as well to the env: CDP API key ID, API key secret, and a CDP wallet secret. One important note: make sure that you never reveal the secrets to anyone. These are very sensitive credentials. So make sure that you never commit this file to GitHub or to a public repository, and also make sure to keep all of these credentials secret. So now that we have discussed EMVs, now we can move to main file and set up our Node.js code. So before we start with the implementation of this Solana policies, we need to get the info for the IDL-based policy as well. So IDL here means interface definition language, which is a JSON file which describes the program's instructions and the program's information. So in our case, it will be Jupyter V6 aggregators IDL file. So this would provide us with all the information and all the instructions of the program. So you can compare this with the ABI or the application binary interface in the Ethereum blockchain. So if you're an Ethereum developer, this idea is simply the ABI of all the programs that work on the Solana blockchain. So we need to get this interface definition language, how we do it for the Ethereum blockchain as well. So we can just go to the block explorer and get the idea from there. So just navigate to sourcecan.io, and once you navigate to the sourcecan.io, you can check for this address. So this program address is the Jupyter aggregator V6 program address. So here in the options for the transaction options and the various other options, you will just find the program IDL over here. So you can just click on this, and you can download the program IDL directly from the Solana scan itself. So Solana Block Explorer. So just download this program IDL into the directory, and you can use this program IDL for creating Jupyter V6 based Solana policies. So I downloaded the Jupyter Basics ID before itself, and I've added it to our directory as well. So here you can find the Jupyter Basics ID.json, and as you can see, it provides all the information regarding the program from address to metadata to all the instructions. So we can use this instructions to directly create policies for our accounts and our project based on the Jupyter Swap aggregator. So now that we have all the prerequisites set up, so let's start with the Solana.ts. So first, we'll start with the imports and the CDP client initialization. So I already have them over here. So the imports are going to be very simple. First of all, we have the CDP client import from the CDP SDK and .ini import and the Jupyter IDL import that we just imported or download from the Solana block explorer. And make sure that you have kept the type to JSON because Jupyter v6 IDL is in JSON format. Once it is in, we load the CDP credentials and other ENV files from .env using .env.config. Initialize the CDP client. So the CDP client automatically pick up the credentials from a .env itself. So now we need to worry about separately initializing them. Once that is done, we add a console log that CDP client is initialized successfully. Now that we are done with the CDP client initialization, let's start writing out our policies. First, we'll start with the simple policies and then we'll move to the advanced Jupyter v6 based policy. So the first fundamental policy that we are going to implement is an address allowlist based policy. So these types of policies make sure that there are no malicious or blacklisted addresses allowed in any kind of server wallet transactions. So I already have the code over here. So here we have this salt address allowlist policy, which would be our first policy implementation. So this policy only permits sending salt to a specific list of virtual addresses. Let any attempt to send salt and serve will be blocked at the API level. So we have the function create salt allowlist policy with the parameter CDP client. Then we have a function node which shows that it's creating an salt address allowlist policy. Next, we have the main policy itself where we use a cdp.policies.create policy function to create policies at the account or the project level. So here the create policy function can create a new UVN or a new Solana policy as well. So in our case, we would create a new Solana policy. Then we have the policy body. So here in the policy body, first we have the various parameters like the description. The description in this case would be allow salt transfers to treasury addresses. Scope would be account. So as it's an address allowed based policy, the scope would be account based. So this policy will be applied to specific accounts. Then we have the rules, which is the most important array for this policy body. So in this array, first of all, we have an object which takes the parameter action. So in this action, it takes two types of parameters, which is accept or deny. So in this case, the parameter would be accept and the operation would be sign salt transaction. So in this case, as it is related to signing salt transactions, that's why we have kept the operation to sign salt transaction. And then we have the criteria array in which we have the object type, which would be salt address, and here we add the addresses. So in this case, the address would be the allowlist addresses, or this is the trusted addresses which would only permit sending salt. And the operator would be in, so the two addresses must be in this list. So basically, all of these addresses will be in this list, and only these addresses would be allowed on this salt address allowance. So once that is done, we console log with the policy ID so that we can use the policy ID to add this policies to account level to any accounts or to any CDP server wallets that are created using this CDP client. And then we return this policy ID. So that's the first fundamental policy that we have, which is salt address allowlist. So you can create any kind of address allowlist using this specific implementation. You can add more addresses in a specific implementation or make sure that only certain amounts are sent. So once this is done, now we can move to the next fundamental policy, which should be token restrictions. So I already have the next policy over here, which should be related to token restrictions. So I'll just push it over here. So the second policy would be SPL token mint restrictions. So in this case, this policy would only allow transfers of specific SPL token, which would be USDC in this case. So for example, if you want a protocol or as a developer, you want to make sure that only specific SPL tokens are allowed for transfers, you can use this SPL token mint restriction. If you want more SPL tokens, for example, USDC, Jupyter tokens, or any kind of tokens, you can use these policies to make sure that only those transfers are allowed or only those specific SPL token transfers are allowed. So in this case, this policy checks the token mint addresses. So we have the function create stablecoin and the policy as USDC is a stablecoin. That's why we have named this function like that. The parameter would be CDP client. Then we have the console log. And then we have the USDC mint address. You can find this USDC mint address on Solana blog store, like we found the Jupyter program IDL as well. Next, we have the policy body. So we use CDP policies.create policy with the policy object. So first we have the description, allow USDC SQL token transfers only. Scope would be account. So if you want this to for project as well, you can use project as well. But in this case, the scope would be account. And then we have the rules. So this rules would be an array. So in this array, we have the object where the action would be accept. The operation would be sign salt transaction. So again, this is sign salt transaction based policy. And then we have the criteria. This is again, criteria is one of the most important distinctions which makes sure that how policies would work and how different policies are distinct from each other. So in this criteria array, we have the object which should be type mint address, as this policy is related to tokens mint address. In the addresses, it will be USDC mint address. You can add more addresses to this if you want more SQL tokens to be added. And then we have the operator in. So in this operator in, it would make sure that it only allows transfers of USDC in this case. So for example, if you add USDT as well, so it would allow USDC as well as USDT tokens. So as a reason, we console like this and with the policy ID and return the policy ID. So now that we are done with both of the fundamental policy implementation, which is address allowlist and token restrictions, now we can go to more advanced use case, which would be an IDL-based policy based on Jupyter V6 aggregator. So for the final advanced IDL-based policy, we have already followed the prerequisites, which is getting Jupyter V6 IDL.json and the address from the Solana blog explorer. So now that we are done with those, let's implement the advanced policy. I already have the function over here. So as you can see, this would be policy 3 and the last policy, which should be an advanced Jupyter swap policy, where we'll be using source data plus the minimum IDL. So we'll be extracting the minimal IDL from Jupyter V6 IDL JSON. So this will validate instruction data against the minimum inline data built from again Jupyter V6 IDL.json. So the effect would be it only allows signing Jupyter route swipes when the amount is less than or equal to 1 sol. So anything greater than 1 sol and anything greater than 1 sol would be automatically removed. So for example, if a server wallet is used to do a Jupyter swap, which is where the amount is greater than 1 sol, that would be automatically rejected because we created this policy where all the swaps should be less than or equal to 1 sol. So when other transactions won't satisfy this rule. So here we have the implementation. So we have the function create Jupyter swap policy where we take the CDP client parameter. Then we have the console log and the constant. So first the constant will be max swap among lampposts. So this lampposts converts to 1 sol. So lamppost is basically the base unit for the gas token. So in this case, the gas token is of course also. So this amount of lampposts converts to 1 sol. And then we have the Jupyter program ID that we obtained from the Solana blog explorer. In the reason, we build a minimum inline IDL for the route instruction for the API. So in this case, we first will make sure that the Jupyter IDL instructions contain the instruction related to route as well. If in case it doesn't, it will throw a new error. Jupyter IDL does not include route instructions. Once that is done, we create the minimal inline IDL. So const Jupyter route IDL with the address and the instructions. So in this case, the name would be route with the discriminator and the arguments. You can directly find this from Jupyter V6 IDL.json as well. So once that is done, we'll create a policy which should be created using CDP policy.create policy. So here in the policy object, we have the description first. Allow all USDC swaps on Jupyter max 1 sol. Scope would be account. And then we have the rules array with the object where we have the first parameter action accept operation sign sol transaction. We've already discussed before. Next, again, the most important part, which should be the criteria, which should make this distinct from other policies. Here in this array object, we have the type sol data with the IDL passed in. So in this, we'll pass the Jupyter route IDL that we constructed before. Once that is done, we have the conditions. So these conditions would make sure that the policy instructions are being or the policy conditions are being followed properly. So in this policy conditions array, we have the object where the instruction would be route, and then we have the guardrail, which would be limit maximum input amount for swaps. So this is the main important part over here, which is the guardrail itself. So this guardrail will make sure that the maximum input amount for swaps is set up. So here in this parameters, we have the name in amount and the operator with the value max swap amount length. So this will make sure that the maximum input is set up for swaps. Once that is done, we'll finish up the policy, and then we will console log with the policy ID and return the policy away. That's how you create advanced Jupyter or any kind of advanced policies or using IDL-based policy engine from CDP Server Wallets V2. So you can use this with any protocols that you like. So in this case, we are using Jupyter protocol. There are other protocols in Solana as well, and you can combine all of these protocols and create an advanced policy of your own as well, according to how your project defines what your project wants. So once that is done, we'll create the main function which should combine all of these policies and execute the policy on the CDP infrastructure. So now I'll finish this script with the main function, which I already have over here. So in this main function, we'll create 3 policies in the sequence and make sure that all of them succeed and are executed properly. So first we have the console log, and then we have the try catch block. So first we create the foundation policies, then we create the advanced IDL-based policy, then the console log, and then we have the error block. And if in case there were errors during the policy creation, it will throw the error as well. After that, we execute the main function with proper end. So that's it. We are done with the Solana.ps file, where we implemented 2 fundamental policies and 1 advanced policy. So now let's test this out and see if the policy execution works out. So now for testing this script, first let's run npm engine. So I've already set up those scripts in my package of this one. So build and Solana. So I just run npm run build. So the build wasn't this one. Once that is done, let's run npm on Solana and see if the policy implementation was executed and we get successful policy IDs. Publishing in Solana. As you can see, it created a Solana address allowlist policy, and it successfully created the allowlist policy with the ID as well. And a stablecoin-only USDC transfer policy was added with the ID as well, and an advanced policy for Jupyter Search as well. So all of the 3 policy implementations were successful and were executed successfully on the CDP client. So now any kind of accounts from this CDP client or from this CDP client server wallets will successfully make sure that all of these policies are implemented, and like the address allow list and the stablecoin and the Jupyter Search policy, and make sure that all of these policies are properly followed. And also, if you want to verify this once again, you can actually verify if these policies were executed directly from the CDP portal. So just navigate to the CDP portal server wallet section. So here in the server wallet section, you can find all of the server wallet related details like accounts, wallet secret, etc. And in these policies, you can see all of the 3 policies that we implemented using our script are being shown here. So first is the allow SOL transfer to treasury address. Next would be allow USDC SPL token transfer from DIP, and allow SOL USDC swaps on Jupyter Max 1 SOL. So this gives us one more verification point that all of the policies were successfully implemented on the CDP client, and that's it. We were successfully able to cover fundamental policy implementations as well as advanced IDL implementations. Now you can create all of this or implement your own policy implementations for your own protocols or own projects as well, and make sure that your projects are safeguarded. Congratulations, you have built a sophisticated and robust security script for a Solana backend using client-based developer platform Server Wallets V2. We have covered the entire spectrum from basic transfer patterns to complex protocol-specific interactions. By leveraging policies, you can automate on-chain actions while dramatically reducing the risk of compromised keys or application bugs. This architecture is the foundation for countless secure applications, from DeFi automation bots to on-chain gaming backends. Now it's your turn. Fork this code, find the ideas for your favorite protocol, and start building the next generation of on-chain secure backends on Solana. For more details, check out the official CDP Server Wallets video documentation at docs.cdp.coinbase.com and join the conversation in the Coinbase Java platform Discord. Also, make sure to check out Heimdall's.com for more such advanced tutorials and guides on Web3. If you found this guide from Heimdall's valuable, please hit the like button, follow for more guides, and share it with other builders. What kind of backends would you build with the Solana policy engine? Let us know your ideas in the comments below. Thanks for building with me today. See you in the next one.